First, we're going to look at voice recognition for making the task of measuring all your batteries easier. I've got 80 of them, and so I've ground through it many times this way. And after, the point is I'm voice editing, or I'm voice recognition into an Excel spreadsheet. So when you're done, you got all your data in an Excel spreadsheet, and you can do some arts and charts and graphs, which I have done. And when you see the graph, you say, huh, what is that? Because there's a spike or a dip somewhere you never expected. So, we'll get going here. Which one is it? Right about here. Oh, I wanted to show you first. You all have voice recognition on your PCs, if you didn't know it. And all you got to do is go to the control panel. Today. Go to the speaker, which is the sound icon. Hit that. And this is your output. This says playback up here, so this is your output. But right next to it says recording. So if you click on that, and then if you've got a microphone installed or you're using the mic on your PC, you go there, and you say configure your speech recognition experience. And it has you set up your mic. There's a speech tutorial, but what they do is they put the words on the screen, and then they want you to speak the words back. So as you're going through the tutorial, the software is learning your voice. And it kind of works after that. But if you want really good accuracy, you need to train your computer to better understand you. That's 15, 20 minutes. And again, they'll put a sentence up on the screen, you read it. If you miss a word or something, it doesn't go away. You just repeat it again, and then you get the next sentence. And the content of that is a further education on how to use the system, how to use the speech recognition. And it's pretty painless, takes you about a half hour. And then the last thing here is a speech reference card. It's 3 pages, maybe 4, of all the commands grouped in a nice logical way. And then when you're all done with that, you hit speech recognition, and it brings up the system. And so, we'll get going here. I've got it already started up, and I've already got it into an Excel spreadsheet. Just to give you an idea, I'm going to mute this thing while I'm doing the dictation, because I don't think it's going to work out. Fairly cheap, $15, $25. I've got a bunch of them at home. They all seem to work pretty good. It works out, this headset and this PC work out really good. So that's why I use this one most of the time. I dictate all my emails. I hardly type an email anymore. And if I'm doing a Word doc, I usually dictate those too. But you gotta really want to use voice recognition, because it gets a little painful in a Word doc or an email when it doesn't recognize the words correctly. There's an audio, or there's a way you can correct it by speech. And sometimes it works out, sometimes it doesn't. As time goes by, you get better and better at it. And the system learns more about your voice, and it's pretty good. Yeah, my gauge is if I get 3 fingers between me and the mic. Yeah, thereabouts. And this particular one, I'm using a program product, which is Dragon. It's just a product that does speech recognition. And the mic's disabled. I turn the mic on. Okay, this is a test of a wonderful speech recognition system, period, new line, that I'm going to use today, period. Okay, well, I caught the end of it. This is a test of a wonderful speech recognition system. Didn't get but I'm going to use today. The hardest thing to learn to do is just to speak naturally. Don't punctuate your syllables and stuff. Just ramble on. It turns out better if you speak normally. It's going to record the whole thing. I love it. Okay, turn it off. One of the tricks they do is, if they're in doubt about a word, they look at the words either side of it, and they have a statistical table that says if you use word A, odds are these two words are before it and after it. So they use that kind of stuff too when they're in doubt. All right, we'll get rid of all this.
You have your caps lock button pressed or something because it's all
Pardon?
You have your caps lock button pressed because it's all in uppercase.
Yeah.
You can't stop yelling.
Yeah.
He's talking so loud. Because it's on the speaker, I think we'll yell.
It was on.
Okay.
All right. Hey.
I think Mulan put in a new set of cells.
Yeah. Delete that. Okay. So what I do is I get out, open up the batteries, and I take, don't we have two pencils here, but you get pretty good at putting both probes in one hand and just walking them down the batteries. That's what I do anyway. I'm hanging on with this hand. And so I'll just give you an example of what I do to actually get the numbers into the system. Now, when it's recognizing just numbers, it's pretty good. Oh, here we go. 3.172, new line. 3.123, new line. 3.456, new line. 3.789, new line. Yeah, I think if you this machine isn't this laptop's a little old, but if you had a newer laptop that was running faster, I think the numbers would appear more or less as you spoke them.
Wait for it.
I love it. Yeah, see, I think this machine isn't this laptop. Okay. Here somewhere. Oh, he's going to say that now too. What is 3.723, new line. 3.516, new line. 3.111, new line. 2.999, new line. You get the idea. Turn the beast off. Well, I said, turn the beast off. But yeah, so you get the idea of that. And now we'll just bounce over to my actual cell log, what I did.
That's normal.
I numbered my cells, wrote out them with a magic marker, and charged means a charge that was sat overnight. Discharge means I came back into the garage like on empty, and then let them sit overnight. And because the rationale being, well, to determine state of charge, you got to let it rest. So these are all the numbers I recorded, and then I just did a little subtraction here, and so I got the difference between charged and discharged. And, I was looking at that, I'm saying, that's not enough. And you come down to the bottom, and my pack voltage after a full charge was sitting right up there. And then this was my motor controller cuts off at 237. And then I let the battery sit, and of course they float back up. And so the difference in the whole pack voltage was 24 volts, but when you come down to the average voltage change on the individual cells, it was 0.3. And that's when I began to realize that, that waiting the 24 hours on a discharge side, since I was treating the pack as a unit, is a don't wait. Next time I do this, I'm just going to drive in on empty and start measuring cells. All right. So the interesting part is you put it in an Excel chart. Now, green is charged. Everybody looks good except for these 5 batteries here. And then discharged, even after they rested for a long time, you got a couple of low ones here. This one is real interesting. I never noticed that before, just looking at the numbers. And then these batteries here, these 5 are bad guys too. The story on these 5 is, you know, I bought the batteries from Jack. I had them put them in a corner, and we pushed a truck into there on the lift, and then we built the battery pack up and everything else. And they had shorted me 5 batteries. So okay, we just went out there and opened up a crate and got 5 more batteries, put them in. And these are the batteries. These 5 here are the ones that we took out of a different lot or a different crate. And they behave different. I've tried, you know, when they're in this state, kind of top balance them individually to get them back down. And I've tried down here to charge them to get them back up into line here. Nothing seems to do much good. So that's the way they are. The other advantage of, just getting the stuff in a spreadsheet says you can visualize it, and that really helps. Because, this guy, of course, is the one right above it. Oh, this here is the change in the battery voltage. The change in the individual battery voltage. And this line here is 0.5 volts. And so you can see these guys changed a whole bunch. What I read out of this is these batteries have less capacity than the other 75. And so, okay, they don't seem to be running into dangerous territory on either high or low, because this is like 3.5 volts. 4 volts will be up here somewhere. And so that's it on that one. Any questions? Okay. The other little demo I got is, where did it go? Is ladder logic. Let's see. And ladder logic, I'm thinking, is this one? Yeah. When I had to commit to a motor and a controller and start wiring the CAN 2 or CAN bus stuff, nobody down here had cracked into it yet. So there was no hope of using any of that stuff to control things. So the next best thing is a PLC, which is a programmable logic controller. It's gray, it's that big, it stands about that high, this wide. It basically has, I think anything above 4 volts on the input pin says it's active, and like below 3 volts, it's inactive. And so the input, I think I got some analog inputs in the machine I bought, but I didn't use them. The output is all relay closures. Some normally open, some normally closed. I did not buy a machine that had pulse width modulation outputs, because I just want to keep it simple. But I can add another module on, and I think, you know, I'm going to get fancy here one of these days. So how you program these things, it's called ladder logic. If you've ever looked at the diagram on the back of a washing machine or inside the furnace cover, they are basically the same. The action goes from the left to the right. Now, these are small. I can't make these any bigger, but so I'll speak the labels as I do it. This whole contrivance here is dome light. Now, this says this is a door light switch. Okay. You got 3 modes here. This is the letter E. I can edit things. This is S for simulation. I can run it like it's in the vehicle. And then M is for monitor, which says if I load this program into the PLC, and then I can have the action that's occurring in the truck be represented back up here. So if I open a door, the dome light will come on in monitor mode. So you can see where your program is running. It's for debugging, more or less. Let's go back to simulation. And this is a door switch, and I click on it. I open the door switch, and you can see the red. Doesn't show here, but the line that gets red all the way across through this timer, and the dome light lights. I close the door. The dome light is staying on, and one of 2 things is going to happen. Either this timer is going to time out in, I think I've got it set for like 3 minutes or 5 minutes or something, and it will turn off the dome light. Or if I come down here to the ignition switch and I hit the start button or whatever, the dome light goes off. That's exactly what happens in your contemporary cars. A lot of people don't even realize it, but that's what happens. And so also you can put the manual switch on the dashboard, turns the dome light on. Like this is a big OR, so this or this or this or this will cause an output and turn on the light. And it's the same for the left-hand door, driver's door. It'll go through a timeout equally just as well. And now, ignition switch. We'll turn the ignition switch back off. Okay. This is a real simple one. Headlight switch. You hit it, and the what is that? Oh, that picks the headlight relay, which applies power through the high-low beam switch to the headlights. And then there's a turn signal, or the running lights front and back. And, oh, this was interesting. Hey, this is all stoplights, 4-way flashers, blinkers, all that stuff is all combined into this thing here. We'll take them one at a time. I'm going to put on the left turn signal. And you can see the red. This is an active line. And just doesn't, the red line doesn't show up here, but that goes red and then lights the light. So sure enough, I got a blinker on. I'll turn the blinker off. And just for the heck of it, here's the right turn switch. You get a blinker going. And then 4-way flashers. You flash everything that's on the car. At least that's what I did. I flashed everything. And there again, the power or the signal comes here. And you can see it goes up to 2, goes down to 2, and goes straight away across here to this guy here. Oh, and this, you got the left turn signal on, and then you turn on, and then you put your foot on the brakes. And so you get red lights in the back, and the blinker keeps blinking. There was a bunch of since I was free to do anything in a combination of lights and blinkers and stuff, it was an interesting thought process as what lights would you have blink under what conditions? And some things are hierarchical. They override others. Let me turn this off, turn this off. Emergency flashers, put on my 4-ways, and then do a turn signal. And nothing happens. The 4-ways override the turn signal. I don't know if that's good or bad, but that's the way my truck works. Now to actually program this thing, we're all back to neutral. We'll just go do a little example here. I'll come out of simulation mode and go to edit mode, and I'll do this is a switch, so I'll copy the switch, and then I'll paste the switch. And it appears, they always appear up here, and you slip it into one of these. The little boxes, the nomenclature out here is the actual place or connector on the PLC. So this one says G, this one says I4. So if you go out to the PLC and you go to I, it's 4. All right, so we got that, and we're probably going to want a light. So we'll do a copy, copy, and then a paste, and a paste. Whoop. There's no Gizzy there, hang on. And I gotta get both of these on the screen at the same time. Down here, you plug that in there.
Well, you moved it instead of a copy.
Yeah, that's okay because it was an extra, we're just lying around here.
Okay, I thought
It was not connected
broke
to
something
anything.
before. So.
And so you want to connect them logically. All right, come to here, and you get that little star, and you go to the little star. Hey. There, we logically connected them. And if you turn on the switch, if you go to simulation mode, you turn on the switch, the light comes on. And then, you can, the same basic process, you can add other elements here, timers and gates and stuff like that. It was a lot of fun to do, and it's been working great. One of the nice advantages of the PLCs are they're designed to work in an industrial environment. So it's hot, there's vibration, there's things you don't normally find in the office with your little laptop. So it has proven very robust. I have not had a moment's trouble with it or its power supplies. Questions?
Yeah.
Yep.
What brand of PLC do you have?
I will show you by doing, because I can't pronounce the name. I say Corzite, but I don't think that's it. Come on, machine. It's spelled there it is. It's spelled C-R-O-U-Z-E-T. I think it's French.
Creuset.
Is it French, you think?
Yeah.
Okay. Yeah. I needed a 12-volt power supply for it. Most industrial environments run on 24 volts. So I had a special order power supply, and it was like, 5 weeks. And it was from overseas. Either that or they had to build it just for me. So those are my 2 experiences with some of the not mainstream stuff on the trucks.
What was the cost of the PLC versus buying something like, I forget what it's called. There's a sort of an aftermarket CAN system.
Aftermarket what?
CAN.
Yeah. Yeah.
ISIS.
The question was, what's
Yeah.
the cost of the PLC versus a CAN?
Yeah, there's a, yeah. How much
much
did
did
you
yours
invest in this?
The PLCs were like, I'm thinking like $125 for the power supply, 300 for the main unit, and then like another 150 for the add-on to give me more relay points.
Yeah.
Yeah, it was not cheap. And the reason I didn't go with the CAN stuff was just I didn't know anything about it.
Right.
Nothing. And didn't, yeah.
How many IO points do you have total?
How many IO points do I have?
How many inputs and how many outputs?
12, 24, probably 26 input and 26 output. The input, like I said, are all just digital, you know, just straight voltage levels. The output, some of the outputs are an armature and a normally open, normally closed. Most of them are just normally open. The armature or the relay, these are all built into the PLC. The relays are rated at 8 amps, 250 volts, so they're kind of robust. What I did was right out of the PLC, I put a whole bank of fuses, the little plug-in ones, and I put the fuses 3 amps because I knew I was only driving LED things out in on the car itself, so I figured 3 amps is plenty. And if I, not it, when I, oops, the 3 amp fuse will blow long before the relay gets mad.